Okay, this time let's moving on to the combined gas law. So in this time, the combined gas law is the combination of Boyle's law, Charles law, and Gay-Lussacs law. So will be having this formula: pressure 1 times volume 1 over temperature 1. Pressure 2 times volume 2 over temperature 2. So this is very easy, class. If you are looking for the temperature, I mean the pressure, what are you going to do? You need to put here what is the um what do we call this one? Besides the pressure, it is the volume and the temperature. So you put here volume 2, and where is the temperature you're going to put here? Because since it's in here, so you put here temperature 2. So you cannot cancel out. Cancel out the pressure 2. Okay, both sides. Sorry, I forgot. So put here volume 2, put here temperature 2. So temperature 2 also will be cancelled out. So you'll be having this formula. So you have the pressure 2. So you can write directly pressure 2 is equals to, since it's multiplications in here, this is not division since it's in here. It is multiplications. So you can directly put temperature 2 multiply with pressure 1, volume 1 over temperature 1. Sorry for the words. It should be here. Pressure 2. Then temperature 1 multiplied with the volume 2. That's the final formula. Okay, sure. If we are finding the other and the temperature, what are you going to do? Still, you need to swap them. So put the numerator in the top, put the denominator on the top, and as a numerator, put your numerator as the denominator. That's the easiest one. Okay, like for example, okay, sure, gilibog yaman mi sure. We are still confusing. Put here. Okay, if you are looking for the temperature too, let's put it here. Okay, erase this first. Put here. Okay, if you're looking for temperature 2, you cannot directly put temperature 2 here. Right? I mean, you cannot directly put pressure 2 and volume 2 here, right? So you need also to what? To put them on the top as numerator. So you'll be having a formula of temperature 1 over volume 1, volume 2, volume 1, pressure 1, volume 1 is equals to temperature 2 over pressure 2, volume 2. So you can put directly here both sides, P2, PV2, pressure 2, volume 2. So we'll be having this formula. This one will be cancelled out, and we'll be having this formula. That means temperature 2 is equals to pressure 2, volume 2, temperature 1 over pressure 1, volume 1. That's easy. Okay. Erase this. So, like for example, you are asked to get the pressure, okay? Having this part. So, you can directly input you can directly substitute the numbers, but we need to put first in here. Okay, I think I should put here the right what do you call this one? The right formula that we have. So we'll be having again pressure 2 is equals to pressure 1, volume 1, temperature 2 over volume 2 and temperature 1. Since you're looking for the pressure, we already derived the formula earlier. So next you can write the given. Okay, I'll put the given here. The given are, okay, like for example, this is the sample problem. A sample of gas occupies volume of 2.40 liters at 685 millimeter of mercury and 130 degrees Celsius. What would be the pressure in millimeter mercury if the volume temperature were increased at 5 liters and 210 degrees Celsius? So you're asked to get the pressure. So the first is gas express volumes 240 liters. So this is the volume 1. What's the volume 1? 2.40 liters. At 685 millimeter mercury, this is a pressure 1. You have 685 millimeter mercury. And then you have the temperature, which is temperature 1, which is 130 degrees Celsius. Convert to Kelvin, you need to add 273 plus 273 Kelvin. And then your temperature 2, your volume 2 is, what is your volume 2? Your volume 2 is 5 liters. And then your pressure 2 is being asked. Then your temperature 2 is, what is the temperature 2? You have 210 degrees Celsius plus 273 to convert into Kelvin. Okay, let's convert first. 130 plus 273, you have 403 Kelvin for temperature 1. For the temperature 2, 210 plus 273, you have 483 Kelvin. Okay, now we can solve this. So you need to substitute the formula now. Okay, pressure 1 and pressure 2 is equals to, pressure 1 is 685 millimeter mercury. Multiply with the volume 1, 2.40 liters, then multiplied with temperature 2, 483 Kelvin, then divided by volume 2, which is 5 liters, and the temperature 1, which is 403 Kelvin. Okay, you can directly cancel out the Kelvin since it's the divisions and the liters. So you have this remaining. Since it's divisions, the line indicated with divisions. So liters, cancel out, Kelvin, cancel out. So we'll be having pressure 2 is equals to, okay, multiply first on the top. So 685 times 2.40 times 483, you have 794,052 divided by, okay, maybe I should write it here, 794,052 divided by 5 liters multiplied by 403, you have 2,015. So pressure 2, then now divide them. 794,052 divided by 2,015. We'll be having 394.07. What is your unit? Millimeter mercury, since that's the remaining one. Wala siya na-cancel out. So it just indicates you got the correct answer if you have this certain unit. Don't forget that if you have wrong unit, then you have the wrong answer. You should have the right unit. Okay? Pressure is, you can look in your book the different standard unit, different unit for pressure. Okay, if you have any questions, you can message me through Messenger or in my Gmail account. Thank you for watching. Bye.